Hello children, welcome to digital classes. Children, in today's session, we are going to learn an important concept from physical science about atoms, molecules and chemical reactions. So let us begin the session children. Children, first we will see what we are going to learn by the end of this session today. So in today's session, we are going to learn about the definition of atom, molecule and an element, names and symbols of some elements. We shall define atomicity and valency, and then we will see how to write the chemical formulae of compounds. We will learn an important thing called as the mole concept, and then we will see the types of chemical reactions. So children, let us begin the session today. Children, in our previous class we have understood about matter, that matter exists in different forms. We know that the term pure is different in our day-to-day life and in science. So children, matter is usually classified as pure substances and mixtures. These pure substances again can be elements or compounds, right children? Now let us see some concepts about matter. We know that matter consists of pure substances and mixtures. That is, substances whatever we are using in our daily life can be either pure substances or they can be mixtures. Pure substances are again elements or compounds. Whatever it is, all matter, whether pure or mixture, they are composed of tiny particles called atoms. These atoms are called as the building blocks of matter. Children, while constructing a building, we take the help of bricks, isn't it children? So, if you consider the brick as one unit of a building, then we can consider atom as one building block of matter particles. Atoms are so small that they can't be seen even with a high resolution microscope. So children, we can't even imagine what is the size of the atom, isn't it children? When we can't even see it with a high resolution microscope, can imagine how small or how tiny they can be. So children, what is this atom? John Dalton, an English scientist, proposed his atomic theory, which he has given in the form of 5 postulates. So first let us see what John Dalton had to say. John Dalton was an English scientist. He believed that atoms are the smallest unit of matter, and he proposed his theory with 5 postulates. So children, let us see the 5 postulates one by one. Matter consists of indivisible particles called atoms. So this is the first important postulate of Dalton, where he said that matter consists of indivisible particles. Indivisible particles means what children? Dalton thought that the atoms are the most basic form of the particles in nature. He thought that the atom cannot be subdivided into other elementary particles. Okay children, that is the first postulate. Now let us look at the second postulate. The second postulate says atoms are neither created nor destroyed in a chemical reaction. Reorganization of atoms take place in a chemical reaction. Children, if you remember the law of conservation of mass, yes, we have learned that mass is neither created nor destroyed. It is a constant. So that is how we can say if the law of conservation of mass is true, then the second postulate of Dalton should be true. Atoms are neither created nor destroyed. They reorganize themselves in a chemical reaction. Now let us see the third postulate children. All the atoms of the same element have the same physical and chemical properties. Atoms of different elements have different properties. Like children, suppose we are taking a hydrogen element, then whatever may be the place you consider hydrogen, whatever may be the place you take hydrogen from, it will have the same properties everywhere. If you take one hydrogen atom and one oxygen atom, then they will have different properties. So that is what the third postulate says children. Now let us go for the fourth postulate. The fourth postulate says compounds are formed when atoms of different elements combine in simple whole number ratios. Chemical change is the union or separation of atoms as in whole numbers. So children, here there is no scope of any parts, right children? There is no scope of any parts. The compounds are formed in whole number ratios like 1:1, 1:2, 2:3 in these forms. When atoms of different elements combine in different ratios, they form different compounds. Now, to understand this, we have the example of carbon and oxygen, children. See the formula of carbon monoxide. Yes, carbon monoxide is given by CO, where C stands for carbon, O stands for oxygen. Carbon dioxide, CO2. So here we have mono means one oxygen only, dioxide means two oxygen. So here carbon and oxygen are combining in 1:1 ratio to form carbon monoxide and 1:2 ratio to form carbon dioxide. Children, these two are different compounds. Carbon monoxide and carbon dioxide are totally different compounds. So when the same elements combine in different ratios, then they give rise to different compounds. Children, now let us try to understand what we have been reading. We have been coming across terms like atoms, molecules, compounds, elements, isn't it children? Now let us try to understand each one of them separately. So we know that all substances in matter are made up of atoms and molecules. We also understood from Dalton's theory that atoms are the most fundamental particles. Just like the brick to a building, atoms are assumed to be the building block of the nature particles. Atoms combine to form a big particle called as the molecule. So what is a molecule now children? Atom we have understood. But what is a molecule? A molecule is formed when atoms combine. Okay children? A molecule is defined as the smallest particle of substance that has an independent existence and retains all the properties of the substance. So suppose children, we are talking about carbon dioxide gas. Okay children, if we are talking about carbon dioxide gas, then every constituent particle in the gas is a molecule of carbon dioxide. Are you able to understand children? This carbon dioxide molecule is similar in every aspect to another carbon dioxide molecule. So here we can say that a molecule, a carbon dioxide molecule can independently exist and it will have all the properties of the gas. Isn't it children? Whatever properties the carbon dioxide gas has altogether, every single molecule of carbon dioxide possesses the same properties. Molecules can be two different things again. If a molecule is formed by the atoms of the same element, it is called molecule of element. Here if you see the example of hydrogen. Hydrogen gas is not a single hydrogen atom children. It is formed by the reaction between two hydrogen atoms or the combination of two hydrogen atoms which combine to form the molecule of hydrogen. Okay children? Similarly, if you take the phosphorus atoms, okay children, 4 phosphorus atoms combine to form the P4 molecule, the phosphorus molecule. Okay children, these are called as molecules of elements because this molecule is altogether made up of the same element, hydrogen and hydrogen. This molecule of phosphorus is made up of only phosphorus elements or phosphorus atoms. So therefore these are called as molecule of element. What do we call it if the atoms are different? Let us see that children. If a molecule is formed by the atoms of different elements, then it is called the molecule of compound. Here the example of carbon dioxide can be taken. Carbon dioxide is formed by two different types of atoms, one of carbon and two of oxygen. They combine in a particular ratio to form this carbon dioxide gas. Right children? Again we have ammonia. Ammonia is formed by the combination of one nitrogen and 3 hydrogens. Okay children? So here also a particular ratio is there in the formation of ammonia, 1 nitrogen and 3 hydrogens, that is 1:3 ratio. Right children? So these are molecule of compound, means here the atoms, the combining atoms are different. Here we have carbon and oxygen, here we have nitrogen and hydrogen. So these are molecule of compounds. When the particle of a substance contain only one type of atom, that substance is called an element. So, if the particle of the substance contains only one type of atom, like how we saw hydrogen gas, oxygen gas, nitrogen gas, phosphorus, sulfur, these contain only one type of atom. So, it is called as an element. An element can be a single atom or a molecule. You can consider element to be just one single atom like a metallic atom, iron, or a molecule like hydrogen gas. That is called as an element, children. It is the smallest entity. An element is the smallest particle or a smallest entity which can be an atom or a molecule. Been talking about these elements and atoms and molecules. In general, how do we identify them? Children, how do people identify us? Yes, people identify us by our faces and by our names. Isn't it, children? So, naming of the element is very important to study their properties. So, already 118 elements have been discovered till date. To remember and to study their properties effectively, scientists had to name them. Isn't it, children? So, let us see how the naming process started. There are about 118 elements discovered till now. In order to avoid confusion, scientists have given them names and symbols also. A symbol is defined as the shorthand notation of an element. It consists of one or two letters. Just now we have seen, children, for hydrogen we have used H, for phosphorus we have used P. That is the symbol of the element. Let us see some common elements and their symbols. So, we have hydrogen, oxygen, nitrogen, sulfur, carbon, boron, phosphorus and fluorine. If you observe, children, the first alphabet of the element name is taken as the symbol. Oxygen O, hydrogen H, nitrogen N, sulfur S. Isn't it, children? Carbon C. The main important thing that we have to make a note here, children, is that we are taking the first letter of the English alphabet as the symbol of the element. Right, children? Now, let us look at some more element names. If you see here, children, we have two letters in each case. Now, children, we have carbon starting with the letter C. Isn't it? And at the same time, we have calcium also starting with the letter C, chlorine also starting with the letter C. So, what about elements like calcium and chlorine? What do we name them? Right. In that case, carbon has already been given the symbol C. So, for calcium, we will be taking the second letter also, that is Ca. For chlorine, we are depending upon the pronunciation and taking LCl. Okay, children? And the others follow suit. Lithium is Li, beryllium is Be, aluminium is Al, barium is Ba, bromine Br and helium is He. These are the names of the elements and their symbols. Children, we are going to see another table of elements and their symbols with a difference. We must be already familiar with some of these, children, like sodium symbol, we know it is Na, potassium symbol is K, copper is Cu, iron is Fe, we know all these, children. So, here they are taken from their Latin names, children. See, children, potassium starts with P, but already we have phosphorus starting with P, sodium starts with S, but already we have sulfur starting with S. So, here their Latin names have been considered, like kalium, potassium is called kalium, sodium is called natrium, silver is called argentum. So, hence the symbols are different. For kalium, for potassium it is K, for sodium it is Na, for silver it is Ag, for iron it is Fe and others also similar to their Latin names. So, children, I hope you understood how we got the symbols and how we got the element names and their symbols. Now, children, let us define the concept called atomicity. Children, there are some elements that have more than one atom in their molecules. Can you fastly think of something, children? Yes, element of hydrogen, element of oxygen, we have seen in the example just now, and element of phosphorus, sulfur. So, they are molecules of elements which have more than one atom in their molecule. The number of atoms constituting a molecule is called atomicity. So, the number is called the atomicity, children, which means hydrogen H2. 2 is the atomicity of hydrogen. Let us see a tabular column to understand this better, children. See here, children, argon is monoatomic. Similarly, sodium, iron and copper are also monoatomic. Monoatomic means, children, they exist independently and their atomicity is 1 only. And then hydrogen, oxygen, chlorine. These are diatomic elements. Diatomic means, children, they exist in the form of 2 atoms, H2, O2 and Cl2. And then we have ozone. We are familiar with ozone layer, children, that is protecting our atmosphere with the ultraviolet rays. Yes. So the formula of ozone is O3, which is triatomic. Triatomic, which means atomicity of ozone is 3. Similarly, the atomicity of phosphorus is 4 and sulfur is 8. Okay, children. Now, after understanding atomicity, let us go on to the next important concept called as valency. Now, children, we know that atoms are combining to form either molecules of elements or molecules of compounds. So, how is it that they are able to combine with each other or with other atoms? Every element reacts with other elements according to its combining capacity. The combining capacity of elements is called its valency. So, children, valency is a number which decides the combining capacity of the element or the atom. The valency of the elements can range from 0 to 4. So, valency can be a minimum of 0 and a maximum of 4. Children, now let us see the valency of some basic elements. For helium, the valency is 0. What does it mean, children? Valency is nothing but combining capacity of the atom or the element. That means the combining capacity of helium is 0. That means helium does not combine with any other element. Hydrogen has valency 1. It can combine with one element, and fluorine, chlorine also have one valency each. Oxygen has a valency of 2, which means it can combine with 2 atoms of one valency. Nitrogen has 3 valency and carbon has 4 valency. Okay, children. Now, let us understand what are ions. Compounds formed by metals and non-metals contain charged species called ions. So, children, if a compound is formed by the combination of a metal and a non-metal, like for example, we have sodium and we have chlorine. Sodium is a metal and chlorine is a non-metal. So, they are formed by the charged species of the sodium and chlorine called as ions. An ion is an atom or a group of atoms that can exist independently with charges. So, it is not compulsory, children, that ion has to be a single atom. Ion can be a group of atoms also. They are also called as radicals. So, these charged species called ions are also called as what, children? Radicals. A negatively charged ion is called anion and a positively charged ion is called a cation. Here are some common cations, children. Cations are positively charged. The net charge of element hydrogen is 1 and its symbol is H plus. For sodium it is Na plus. For potassium it is K plus. Ammonium NH4 plus. We have elements with net charges 1, 2 and 3 here. And let us say some common anions. Yes, hydride is H minus, chloride is Cl minus, hydroxide is OH minus, nitrate is NO3 minus. If you see oxide and sulfide and dichromate, they are minus 2 each, that is the net charge is 2 on them, and for nitride and phosphate the net charge is 3. Let us define the atomic mass of a substance. The number of times an atom of an element is heavier than 1/12 mass of the carbon 12 atom is called its atomic mass. So, children, if you divide the mass of the carbon 12 atom into 12 equal parts, then the ratio to which the mass of the atom is heavier than the 12th part of carbon atom is called the atomic mass of the substance or the atom. Atomic mass does not have any units, but it is denoted by AMU, which is called as atomic mass unit or unified mass U. These are some common atomic masses, children, for some common elements that we use usually. Children, make a note of this. For hydrogen, the atomic mass is 1, carbon it is 12, nitrogen is 14, oxygen 16, sodium 23, magnesium 24, aluminium 27, phosphorus 31, sulfur 32, chlorine is 35.5, potassium is 39 and calcium is 40. Children, we have to remember these atomic masses so that they help us in solving problems. Now children, we are saying or we are talking about chemical formula. We are talking about different types of compounds in our daily life also. Like water is a compound, sodium chloride, the salt that we are using, is a compound, glucose is a compound, sugar is a compound, isn't it children? So let us take a small simple method to see how we can write the chemical formula of these compounds. First let us take the example of chemical formula of sodium carbonate. So we will write the symbol of sodium children, Na, and on top of it we will write the net charge on sodium, that is 1. We will take carbonate together children, CO3, and on that we will write the net charge for carbonate, it is 2. Now we will apply crisscross. Crisscross means the 1 will go on this side, sodium's 1 will go to the carbonate side and the carbonate's 2 will come to the sodium side. Okay children, and their positions will also change, they will become the subscript now. See, 1 will go here, the 1 will go here and 2 will come here beside sodium. So therefore, the formula for sodium carbonate is Na2. This 2 is written with sodium here and CO3 1, the 1 is written with carbonate here. Or if it is a 1, we need not mention it separately children. We will write it as Na2CO3. This is the chemical formula for sodium carbonate. Let us see another example. We will write a formula for magnesium sulfate. We have written the symbol of magnesium with its net charge and symbol of sulfate with its net charge. Applying crisscross, magnesium comes to sulfate side, magnesium 2 comes to sulfate side. Similarly, the sulfate 2 comes to the magnesium side. We will write the formula as Mg2. See, this 2 will be beside Mg, so it will become Mg2 SO4 2. But we can represent the chemical equation in the form of the lowest ratio. Okay children, lowest ratio means children it is 2:2, it can become 1:1. We will write the chemical formula of magnesium sulfate as just MgSO4. Okay children, I hope you understood the chemical formula of magnesium sulfate. By the help of the anion and cation chart, you can try to write more and more chemical formulae on your own children. It is a very simple thing. Now children, let us define the molecular mass. The molecular mass of a substance is the sum of the atomic masses of all the atoms in a molecule of the substance. So children, if you want to find out the molecular mass of carbon dioxide, then it is the sum of the atomic masses. We have carbon's atomic mass, we have oxygen's atomic mass. So it is the sum of the atomic masses of carbon and oxygen in the ratio. It is the relative mass of a molecule expressed in unified mass units. So molecular mass is expressed in unified mass. For example, let us consider say H2SO4. What is it children, H2SO4? Yes, it is sulfuric acid. So here H2SO4 consists of 2 atoms of hydrogen, 1 atom of sulfur and 4 atoms of oxygen. So we will write it as 2 into atomic mass of hydrogen plus 1 atomic mass of sulfur plus 4 into atomic mass of oxygen. Substituting the value from the chart, we have atomic masses chart. 2 into 1 atomic mass of hydrogen is 1 plus 32 plus 4 into 16. Total is 98 U. This is the molecular mass of sulfuric acid. Children, you can take some more examples and practice the molecular masses. Let us see what is formula unit mass. Formula unit mass of a compound is the sum of the atomic masses of the constituent particles. It is calculated in the same manner as molecular mass. Then why are we doing it again? Why are we giving it a different name? The only difference is that the constituent particles are ions. So if we are calculating formula unit mass, then we are taking ionic compounds only children. For example, sodium chloride is constituted by sodium plus ion, that is the cation of sodium, and Cl minus, that is the anion of chlorine. Children, let us calculate now. Formula of sodium chloride is NaCl. Atomic mass of sodium plus will be 23U. and atomic mass of chlorine minus will be 35.5 U. So the formula unit mass will be 23 plus 35.5, that is equal to 58.5 U. Okay children, this is the formula unit mass of sodium chloride. Children, now let us come to an important concept called as the mole concept. Mole is a unit for measuring the quantity, especially for expressing the number of particles. A mole of a substance is the amount of the substance which contains as many particles that are equal to the atoms present in exactly 12 grams of carbon 12 isotope. So this is a number children, it represents the number of particles present in a substance. The number of particles present in 1 mole of any substance is 6.022 into 10 to the power of 23. This number is called as the Avogadro's constant. Let us try to understand it children. 1 mole is equal to 1 gram of hydrogen atoms, which is equal to 6.022 into 10 to the power of 23 atoms of hydrogen, which means 1 gram of hydrogen atoms consists of 6.022 into 10 power 23 atoms. Okay children, in 1 gram of hydrogen atom, I am taking only atom children, not molecule of hydrogen. 1 gram of hydrogen atom consists of 6.022 into 10 power 23 atoms of hydrogen. Similarly, 16 grams of oxygen atoms, what is this children? This is the atomic mass, isn't it? The 16 grams of oxygen atoms is 1 mole, and this 16 grams of oxygen consists of 6.022 into 10 power 23 atoms of oxygen. Similarly, 32 grams of oxygen molecule has same number of particles, 6.022 into 10 to the power of 23 molecules of O2. Here it is just O, here it is O2. And 2 grams of hydrogen molecule consists of 6.022 into 10 power 23 molecules of hydrogen. These all are 1 mole each children. Now let us try to understand molar mass. The mass of 1 mole of a substance expressed in grams is called its molar mass. Molar mass is numerically equal to molecular mass and is expressed in terms of grams. For example, molar mass of water is taken as 18 grams. So what is the difference between molar mass and molecular mass? Molar mass is expressed in the form of grams. 18 units of water has only 1 molecule of water, but 18 grams of water has 6.022 into 10 power 23 water molecules. So this is 1 mole children. 18 grams of water is 1 mole. Children, now let us see chemical reactions. A chemical reaction is a process that is characterized by a chemical change in which the starting materials are different from the end products, that is, reactants are different from products. In a chemical reaction, atoms are neither created nor destroyed. Some different types of chemical reactions children. A chemical reaction in which a single product is formed from the combination of 2 or more atoms is called chemical combination. 2 Mg plus O2 gives rise to 2 MgO. So here magnesium and oxygen are combining to form magnesium oxide. 2 elements are combining to form 1 compound. This is called as chemical combination. Next we will see chemical decomposition. A chemical reaction in which a compound decomposes into 2 or more elements or compounds is called chemical decomposition. So here one substance, calcium carbonate, decomposes in the presence of heat to form calcium oxide plus carbon dioxide. The next one is the displacement reaction. A chemical reaction in which one element replaces another from a compound is called displacement reaction or substitution reaction. See this equation children, zinc plus 2HCl hydrochloric acid. When you add zinc to hydrochloric acid, we have the formation of zinc chloride and hydrogen gas. So here zinc is displacing hydrogen. So this is called as a displacement reaction. The last one, double displacement reaction. A chemical reaction in which 2 reactants exchange their constituents chemically to form 2 different products is called a double displacement reaction. Lead nitrate, potassium iodide. When they react, they form lead iodide and potassium nitrate. So here nitrate and iodide exchange their places. Children, we have come to the end of this lesson. Now let us take a fast look at what we have learned today. Atoms are the building blocks of matter and is indivisible. Atom is the smallest particle of an element that can participate in a chemical reaction and retain all properties. A molecule is the smallest particle of an element or a compound that is capable of independent existence. The number of times one atom of a given element is heavier than 1/12th part of mass of carbon 12 atom is called its atomic mass. The number of particles present in 1 mole of any substance is called Avogadro constant, given by 6.022 into 10 power 23. Mass of 1 mole of a substance is called its molar mass, and then we have seen different types of chemical reactions. Children, take a look at these questions and try to answer them. Define an element, differentiate between molecule of element and molecule of compound, find the chemical formula of ammonium chloride and sodium sulfate using crisscross method, calculate the molar mass of calcium carbonate, and discuss the different types of chemical reactions. Children, I hope you understood today's lesson. Try to answer the questions given in evaluation. Let us meet in the next session with much more interesting topics. Bye children.
గుంటూరు శేషేంద్ర శర్మ గారు ప్రముఖ కవి, విమర్శకులు. కవితా సాహిత్యం